You're listening to the HyDeploy podcast, a conversation about introducing hydrogen to the UK's gas network. Hydrogen is recognised as a viable green fuel for homes and industry in a net zero future. And since the recording of this podcast, the second phase of HyDeploy has gone live, and the community of Winlayton near Gateshead is now receiving hydrogen blended gas. This episode, while accessible and interesting for a general audience, is particularly aimed at gas-safe engineers. Let's find out more. Well, welcome along everybody to this episode of the HyDeploy podcast, which is a discussion about hydrogen and its use as a green and sustainable fuel for heating, cooking, industry, and even transport. Now, this episode is particularly aimed at gas-safe engineers, and we're going to be looking at what the hydrogen revolution means for them. So, for example, if we're all going to be frying our eggs and powering our central heating on hydrogen in the not-too-distant future, what will that mean if you are an engineer? Will you need to retrain? Will you need to adopt new procedures and equipment? Well, we're going to find out. And to help us answer these questions and many more, we have four experts in this field, all of whom boast very impressive CVs. So let's do the introductions first. Adam, should we start with you? Just tell me a little bit about who you are and your organisation.
Morning, Nick. Morning, everyone. My name's Adam Madgett. I'm the HyDeploy project manager for Northern Gas Networks. So I've been leading on the HyDeploy project from when it started in 2017. And Northern Gas Networks are one of the gas distribution networks in the UK who transport gas to your house, my house, anyone who's got gas, basically.
Thanks very much, Adam. And Lorna, do you want to tell us a little bit about yourself?
Good morning, Lorna MIllington. I work for Cadent, another one of the gas networks. We transport gas to about 50% of the UK, and I'm a future networks manager within Cadent and our strategy team, and I've been involved in HyDeploy 2 since it began, mainly focused on the technical side, but been glad to see the progress it's made.
Fantastic. Look forward to quizzing you about that shortly, Lorna. And Paul, tell us who you are and the organisation you represent.
Yes, I'm Paul Richards. I'm the Principal Mechanical Engineer at Keele University, which is based in Staffordshire. My job basically is to look after all things mechanical on the Keele site, and I'm also responsible for the gas network. We've got a private gas network on site.
We'll delve into that shortly as well. And then finally, Tommy, who are you and what's your organisation?
Good morning, Nick. My name is Tommy. I'm the Principal Engineer for Progressive Energy. We are a low carbon project development company. So we are the developers behind HyNet, which is a major low carbon hydrogen project in the northwest, and we've been on the project management team of HyDeploy since the beginning, securing the funding from Ofgem for both rounds of it, and have been across the project on the technical, safety and operational sides.
So before we go any further, I think we need to understand, first of all, why everyone's getting so excited about hydrogen at the moment. And Adam, I wonder, could you perhaps kick us off by, well, just telling us really what's so great about hydrogen and what we mean by blending hydrogen?
Yeah, no problem, Nick. So in 2019, the UK signed into law that we will become net zero by 2050. What does net zero mean? It basically means we have to reduce all of our greenhouse gas emissions by 2050. So why are gas networks like Cadent and NGN looking at this? And the main reason for that is that we transport natural gas to customers' properties. And at the moment, the reality is that when we burn natural gas, it reduces carbon emissions to the atmosphere, and over a third of carbon emissions come from heating. So, you can see how important it is to tackle that area. So when we talk about hydrogen, it's a clean element. So again, clean element, basically what does that mean? It means that there's no carbon in hydrogen. So when we burn it, there is no emissions. So you can, when you start thinking about that concept, you think it's a no-brainer. If we could use that, why can't we introduce that into the network? So from a HyDeploy perspective, we've been looking over the past how many years now? Is it 4 years? We've been looking at how we could safely introduce a blend of 20% hydrogen by volume into the gas network to reduce carbon emissions. And I think it is the most important thing about HyDeploy is that if we introduce a blend into the network, the networks themselves and customers don't have to make any changes to their appliances or the behaviours. So when you think about that compared to other low carbon heating schemes and mechanisms out there, there are significant changes that have to be made in terms of customers' properties and appliances and things like that. So if we can introduce a blend into the network safely, which so far we have proven it is safe to do so, then we can significantly reduce carbon emissions without having to make any changes to customers. And just to put some sort of figure that's relative to people on what carbon emissions we could reduce, or what number we could reduce by. If we were to roll it out across the UK, it would be equivalent to taking 2.5 million cars off the road. So that's quite a powerful reduction in carbon emissions without customers having to do anything at all.
Yeah, that's quite amazing, really. And that's just through blending alone. That's before you even get to 100% hydrogen, presumably. And when we're talking about blending, do we regard blending as a sort of end in itself? Or is this really to sort of warm the public up to the possibility of 100% hydrogen?
So blending is absolutely a transitionary stage. It is the first step of the hydrogen journey. By allowing hydrogen to be adopted without making changes to anyone's appliances, it allows a supply chain of hydrogen to be built up to quite material quantities, as Adam has outlined, and then you've already broken that chicken and egg, which means you can then start to build on top of it in a very incremental manner. So that's why we're blending first, is because it starts us on the journey. And then once we've got a supply chain of hydrogen established, you can then start to look at sectorising the gas network and all of its users to then build out pure hydrogen.
Now, obviously, HyDeploy really is the sort of pin-up for hydrogen blending in the UK. And perhaps you could give us an overview, Lorna, of what HyDeploy is and what's been going on at Keele.
Absolutely. So when we put this idea together, we actually thought 20% blend was really pushing the boundaries. And it was quite interesting to see as we started to build the evidence and prepare ourselves to do the project. We realised it wasn't that big a step as we thought it was. But that was great because it actually meant that it was a much more comfortable step than we'd originally anticipated it would be. But basically, Keele University approached us as an opportunity to do work on their site. They're very keen, and Paul will, I'm sure, support the fact that they really have been looking at what they can do to decarbonise their site. They own and operate their gas network, which from a gas network's perspective means we don't have to make large-scale changes to be able to accommodate the project. As Adam will talk to later, the second stage has moved on to our networks, but that first bit de-risked. It helped us to get started. Taking on a small portion of Keele's network to do this project was an excellent choice. But all we needed to do was build a plant to produce some hydrogen, build the stuff to be able to blend it together, and put it into a gas network. It sounds really straightforward. Those bits were reasonably. The big pig was making sure that we'd got all the safety evidence to prove to our safety regulator, the HSE, that it was safe to do so. Get the consumers on Keele campus ready to go. And those two bits were probably the bigger challenges. HSE, we took them on the journey as we built the evidence, we showed them, we prepared them. And we did the same with the consumers. They had their piece to play because we had to make sure that they knew what was coming. Check their appliances. We had to go into everybody's home within the area, and the particular area we chose within Keele have got a mix of commercial, so the university's labs and other buildings, along with domestic properties, some privately owned, some owned by the university. So we really had quite a good mix, and getting used to the fact of talking to consumers who own their own home, who have concerns about things like simple things, maintenance contracts. Does my maintenance contract still hold if you put blend in there? What does it mean to me personally about what's going to happen through this trial? So we had all those questions to answer, allay fears, but actually, relatively speaking, very little of that compared to what I think I expected when I started the project, which is a real credit to both the team, but also our preparation. Half of winning this battle is the preparation and being ready to answer all those variety of questions that consumers will inevitably have. So we've been blending 18 months, and It's been the biggest no-show as you would expect and hope it to be. No bad feedback. Really, the nothing that we hoped it would be. No difference noted. Everyone has seen their appliances work as they did before. It was absolutely brilliant. The first step was the perfect one on the road towards blending.
That's fantastic. And yeah, it's one of those rare occasions where you say it was a no-show, but that's a good thing on this in this instance, really. The fact that people didn't notice the difference, that's kind of the whole point, really, isn't it? That's fantastic. And Paul, obviously you've been looking at you're the technical mastermind behind all of this that's been going on at Keele. And one of the really important aspects of the whole trial is to look at how the existing gas network coped with all of this, how people's boilers and cookers coped with all of this. Can you give us some sort of oversight about the slightly geekier technical aspect of this, and how existing equipment has performed with a 20% blend flowing through it?
Yes, certainly. I mean, as Lorna said, just to give some background about Keele University, it's rather a unique campus. It is a campus university. It's around 600 acres in size. We're located in Staffordshire. It's like a small town, really. We've got, about 101 residential houses, 8 multi-residency buildings, 17 extensive office blocks and laboratories, and 7 recreational and service facilities. And the key thing with Keele, it does own its own infrastructure on site. So we run and own our own gas infrastructure. We're a licensed transporter and supplier of gas. We've got our own water network and electrical distribution network. And Keele's developed something called a Smart Energy Network Demonstrator. So it's ideally situated to engage with external organisations for environmental and clean energy research. So the HyDeploy project really fitted in really well with the ethos at Keele, basically. And as was mentioned before, to operate a commercial and domestic gas installations on site, we have to provide a gas safety case to the Health and Safety Executive, and that has to be submitted every 3 years. So a real big part of the HyDeploy project has included extensive engagement, and a number of checks and balances have had to take place before we can get what's known as an exemption to our safety case to blend 20% hydrogen at volume. And I think there was about 18 months' work by Progressive Energy and the team, basically including a review of over 200 procedures, some appliance and installation testing, looking at gas characteristics, detection, dispersion, migration, ignition, and a material assessment. Now, all this was done prior to actually starting at Keele, utilising the health and safety laboratories at Buxton. And as Lorna alluded to, an enormous amount of work to get the exemption for us to start the trial. And then even before we started the trial, a number of tests had to take place. We did a baseline data, including a survey of all the assets and equipment on the gas network, tightness testing of all gas installations, which is a routine and periodic exercise that we carry out anyway. But we did a comparable on the gas network that we were blending. So we used bottled gas with a 20% hydrogen mix and did a comparative on the drop tests in all the appliances that we had on site that were going to be used as part of the trial. There was testing of specialised gas detection equipment that was to be used during the trial. And when the trial commenced, there's been a number of tests carried out for both normal operations and for research purposes. And these have included, monitoring and reporting gas escapes and carbon monoxide incidents. We used 6 test stations, which were positioned on the network, and they were to monitor gas pressures, gas concentrations of hydrogen, and also gas odour, which is very important because that's what people pick up when there is a gas escape. We used 8 test boilers, and these were supplied from 4 leading manufacturers, and they were installed on the network, and they ran to simulate 18 equivalent years of use. Each manufacturer had 1 boiler running on natural gas and 1 boiler running on the blended gas during the trial. and these boilers have been returned to the manufacturers for detailed analysis, and maybe Tommy can expand a little bit on maybe some of the findings that they've had from there. A new type of gas chromatograph or gas analyzer was installed, which recorded the constituents of the gas and the hydrogen content. This was really useful to give real-time analysis of the hydrogen concentrations in the network. So it demonstrated basically that the hydrogen remained at a consistent volume with the blend, whether it was set at 10%, 18%, 20%, etc. So that was able to show us that the blend remained consistent over the network, and that network could be many miles long. Materials as well. We had some material coupons placed in an atmosphere of blended gas, and that's basically to reinforce the laboratory checks that were carried out. And these were done on typical materials that you would find on a gas network, such as steel, cast iron, brass, etc. And so some of the key issues to demonstrate on the trial was sort of short and long-term appliance behaviour. And we've got catering on site as well as domestic properties, etc. The effects of hydrogen on the materials, any risk of poor or inconsistent mixing of hydrogen, hydrogen detection equipment, and also a big thing, the customer perceptions. It was one of the things that was quite heartening was the staff at Keele and the homeowners at Keele really bought into this trial, and they were really enthusiastic, and they really embraced it. And again, we had absolutely no reports of any instances, any complaints from the users on site. And from the commercial side, the boilers behaved themselves within the commercial catering outlets. Again, there was no sort of complaints that the eggs weren't being cooked properly or the cakes weren't rising, etc., etc. So it was really good. So I mean, overall, I think the technical outcomes from the site trial, I mean, Tommy can perhaps talk about when they may well be produced, but from a Keele perspective, and as Lorna has alluded to, a no show. Basically, it really was a very interesting engineering project to take on, and I hope that the outputs from this trial will go a long way to help the rollout of blended hydrogen across the UK.
Fantastic. Thanks very much for that, Paul. Absolutely fascinating, actually. And Tommy, there may be a few things you want to pick up on there. I mean, things like, for example, this Pepsi challenge between the hydrogen boilers and the natural gas boilers, with simulating 18 years of use, for example. Now, I know some of these reports are yet to be finalised, but anecdotally, it sounds like there've been very few anomalies in terms of the way equipment such as boilers has performed with the hydrogen blend flowing through it. And I just wonder what that means in your opinion for rolling out this blending more widely in the UK, and what that's going to mean for gas safe engineers if they're now working in properties which in just a few years from now maybe have got a 20% blend flowing through the pipes.
So what we did was engage with the 4 big boiler manufacturers. So this is Worcester Bosch, Valent, Ideal and Baxi, and they were really on board with what we proposed, which was to have 2 of their boilers rigged up with lots of thermocouples inside. So a thermocouple just measures temperatures, so we could profile the internal temperature of the boilers. And then we installed both sets of boilers, so we had 4 running on natural gas, 4 running on the blend. Now, we installed the boilers and we didn't tell the manufacturers which boiler was installed on which gas. So it was an entirely blind trial to the manufacturers. And throughout the trial, there was absolutely no issues. No boiler shut down, no boiler had an excursion of temperature, or the flue gas readings weren't safe. It all worked exactly how you would want it to work. We dismantled the rig at the end of the trial, and we've provided the boilers back to the manufacturers. Again, they don't know which boilers were operating on which gas, and we've asked them to try and rip them apart, test them, do whatever they want to them to try and identify which one was on the blend and which one was on natural gas. So far, none of the boilers have, or none of the manufacturers have been able to work it out yet, which is a brilliant sign. Anecdotally, it's looking incredibly positive that effectively there was no difference identified in the performance or safety of the appliances. Getting back to your original question of how would this impact a gas safe engineer? So what this all ultimately leads to is that there are no changes that are required for any domestic procedure for a gas safe engineer. So we've done an incredibly extensive review of all of the procedures that underpin all of the competencies for a natural gas safe engineer. So this is both across the IGEM standards and the BSI standards, where we've had an independent procedural expert review all of them, provide a series of questions to us asking how the procedure may change as a consequence of the change of gas, and then we provided evidence to that independent expert to answer those questions and come to effectively an agreement that there are no meaningful changes to the procedures whatsoever to embody any of the slight changes that you might see as a consequence of the change in gas quality. So in effect, there are no changes, and that goes across both the actual procedure itself, but as well as the equipment that's used to administer the procedure. So the flue gas analyzers that are used by the gas safe engineers don't need to change. So it is both non-disruptive from the consumer side, where they don't notice any difference in the performance of their appliances, and it's non-disruptive from the engineer's perspective in terms of installation, repair, servicing, maintenance, etc., etc. The review that we carried out of all of the procedures, we then handed that review to the standard institutes. So we handed it to BSI and to IGEM and said, this is our view of the fact that we think that procedures don't need to change. Please can you now review this and see if you agree? They went through their own reviews through the relevant committees, and they agreed that there was no change to the procedures that was necessary. So that then all culminated into a technical bulletin that was issued to all gas safe engineers, Technical Bulletin 159, issued in March of 2021, that basically summarised that work. It's around 2 pages of writing, but it summarises about 2 years of work. But it all basically concludes that there is no change that's needed for any domestic procedure that's then supported by the standard owners.
I mean, that's brilliant news, isn't it? So, 20% blending ultimately means business as usual for customers and business as usual for gas safe engineers, which is a fantastic result, really, isn't it? And I wonder, perhaps Adam or Lorna could chip in with this, what it also might mean for network engineers, for engineers such as yours who are working out on the pipes on the network underneath the streets. Again, do they need to do anything differently, or is it very much business as usual for that group as well?
I'll cover it off from a HyDeploy 1 perspective, because we learned the most, I suppose, from BAU in that first step, and the reality was there was very limited amount of change. There was one thing that we had to actually change within our procedures for the guys that go out and do gas escapes, because the equipment we use has a little bit of a challenge about differentiating hydrogen from carbon monoxide, which meant that we had to change equipment for the Keele site. So the teams that were potentially on call to go and attend at gas escapes on that site were trained on the new equipment, and we had a capture system to make sure that when those guys went out that they used the right equipment, demonstrated they understood. And the reality is that when we change our equipment in any circumstance, that would be exactly the same process we would go through. So it really isn't a major thing. And it just meant that we went investigating what other equipment might be more valid if this became a permanent setup across the UK. And as a gas network, we see those sort of changes regularly across varying bits of our business. So it wasn't anything to be concerned about, but it was just something to go through.
Yeah, and Nick, obviously with NGM, we've been looking at the next phase of HyDeploy. So looking to introduce a blend into a network in the northeast of England, a village called Winlayton, which is near Gateshead. And so so that next phase of the project is sort of taking it to the next level. So we're looking at 668 domestic properties. And a couple of commercial buildings. So it's so in terms of for our engineers, we've really followed the same process as what was carried out at Keele. So there are some minor changes which Lorna's alluded to. I think as a project we recognise that there is some of the positions. So for example, Lorna spoke about gas detection, but there were also some slight changes around zoning areas with some of our gas installations, and that was only slight. But I'll reiterate that we as I think project know we need to do some more work on that, because the changes that we made, in terms of them zoning areas were really conservative, because we need to do more work on them. But looking for our trial in Winlayton, it's really following the same premise that we have done at Keele, and then I think looking longer term, once we've finished HyDeploy and we've over the next couple of years, and we've gathered that further learning and experimental evidence, we'll be able to really have a definitive answer for upstream engineers on the network compared to natural gas.
So far, so straightforward, really, when it comes to blending. But how far do we feel that we are off 100% hydrogen? I mean, is there an increasing sense of urgency?
We're on a very quick trajectory to it being in a trial phase, in the same way as we are for HyDeploy. So H100, which SGN are running up in Scotland, will see hydrogen introduced into a new gas network within the next 2 years. This stuff is really in the wings, waiting, but it has a longer lead time for it to become deployed large scale. So, it'll go through a lot of what we've gone through HyDeploy, proving how safe it is, how impactful it is, and all the stages are going to look pretty similar, just simply to just show what differences there are and how we go about preparing people for that change. It's going to be a bigger step, but still only a step.
And let's assume that 100% hydrogen does accelerate as we're expecting or hoping it will. Again, if you're a gas-safe engineer in this brave new world of hydrogen, is this going to make a difference to the way you work day to day? Will we see the need to retrain? Will we see the need to introduce new tools? I mean, certainly getting to grips with hydrogen boilers and how they work and so on, at the very least. Tommy, have you got any thoughts on this? I know it's speculation at the moment, but...
Well, it's probably less speculation than you think. So, firstly, on the appliance side of things, yes, hydrogen-ready boilers have been developed. So, principally by Worcester Bosch and Baxi. So, just to kind of unpack the concept of what hydrogen-ready means. So, what hydrogen-ready means, it's very much like HD-ready TVs, sort of last decade, in that you design a hydrogen appliance. So for the boiler, for example, you just design it for hydrogen, and then you back engineer it to work on natural gas. So then the idea is you can sell it to operate on natural gas today, and then it's ready to be converted at the point where hydrogen is then being supplied to the home. So as opposed to then having to take out your boiler, put in a new one, as well as your cooker, etc., which would be very disruptive for the consumer to just suddenly have to change out all of their appliances. The idea is that you slowly, over sort of 10 years or so, you just saturate the market with hydrogen-ready appliances, so everyone's homes are then ready to receive hydrogen when it comes on board. And then at the point of conversion, you then effectively have a gas-safe engineer come in, and then they change out one or two components, most likely for, say, the boiler and the cooker, it'd be the burner. But that's no different to a kind of service done today in terms of time length and components used. So that's the idea, is to try and smoothen the transition. So it's not one big hit all at once, but you slowly start to saturate everyone's homes with hydrogen-ready appliances to make it much easier. Now, when it comes to actually this kind of new world that we'll eventually be in, yes, things will be different. So the gas characteristics of hydrogen are quite different to pure methane, and what that will require is more training and different equipment. But the gas network the gas industry is very comfortable with the idea that we have different procedures and different equipment for different gases. So today we have LPG. So if you're a off-grid home and you have an LPG boiler, you will have a different set of procedures that are used with different gas detector settings relative to your neighbour that might be on-grid that has natural gas. It's really no different to that. And the training modules that will be required for hydrogen are being developed now. So the industry bodies, if you like, are already putting together what those training requirements will be, and it will just be rolled out as required to then make sure that all of the gas safe engineers are then trained to then operate on hydrogen and then have hydrogen ready equipment.
Yeah, and Nick, it's worth adding that there's a huge amount of research being undertaken by the gas networks and NGN in partnership with the other gas distribution networks, including Cadent, in the H21 program, which is building up this evidence to support any changes that might need to be made. So that if people are wondering what's going on in that space, that there's a huge amount of research going on that, including the SGN's H100 project as well. So the gas networks are working together to build that evidence case, to the safety case first of all, to be able to take that next step.
Thanks for listening. HyDeploy is a partnership between Northern Gas Networks, Cadent Gas, Progressive Energy, Keele University, ITM Power and HSE Bespoke Research and Consultancy. For more information, head over to hydeploy.co.uk.